Hi children, welcome back. Today we are going to start our new chapter, that is chapter number 5, circles. So what is a circle? A circle is a curved plane figure. Every point on the circle is equidistant from a particular point called the center of the circle. A circle is a 2D shape and is measured in terms of radius. The word circle is derived from the Greek word kirkos, means ring or hoop. Circles are present in real life, both in natural creation and in man-made creations. These are some of the examples of circles like clock, desk, pizza and wheel, etc. The invention of wheel is an important event in the history of mankind. This made not only the transportation but practical needs easy. Men knew many mathematical facts about circles from very early times. We have studied in the lower classes how to draw circles with their compasses. Now let's study some basic facts about the geometry of circles. Circles. This is the center of the circle, and then next, the line segment from the center to any point in the circle is the radius. The distance around the edge of the circle is the circumference, and here we have the diameter. Diameter is a line segment passing through the center and touching the two end points on the edges of the circle. And as we know, diameter is 2 times the radius. Okay, let's put 2 points on the circle. If we draw a line segment connecting these 2 points, then this line segment is called a chord. In fact, diameter is the longest chord which passes through the center. In this chapter, we are mainly going to discuss about the chords in a circle. Okay children, let's start the chapter. The first topic is circles and lines. As we know that the distance from any point on the circle to the center is the same. So if we mark 2 points on the circle, the center is the point at the same distance from both. We can draw so many points at the same distance from the 2 points marked on the circle. Then, how can we decide which among them is the center? Here, all the points which are at the same distance from 2 fixed points are the third vertices of isosceles triangles, with the line joining these 2 points as base. And we know that such points lie along the perpendicular bisector of the base. So, the center we seek is on the perpendicular bisector of the line joining the points we have marked on the circle. But through this, we cannot find where exactly the center is. So, to find the center, there is a method. If we mark 2 other points on the circle, the center must be on the perpendicular bisector of the line joining these 2 points also. Since it must be on both lines, it must be their point of intersection. From this, we can find out the center of the circle. From this, we arrived at the conclusion that the perpendicular bisector of the line joining any 2 points on a circle passes through the center of the circle. And the line joining 2 points on a circle is called a chord. In general, we can say that the perpendicular bisector of any chord of a circle passes through its center. So children, you have studied in class 8 that the relations between the base and the third vertex of an isosceles triangle can be put in different ways. The first one is the perpendicular from the third vertex bisects the base, and then the line joining the third vertex and the midpoint of the base is perpendicular to the base, and the third one, the third vertex is on the perpendicular bisector of the base. We can rewrite the first 2 statements on triangles as statements about circles by taking the base as a chord and the third vertex as the center. That is, the perpendicular from the center of a circle to a chord bisects the chord, and the line joining the center of a circle and the midpoint of the chord is perpendicular to the chord. Okay children, now let's do an exercise question in your textbook, page number 68. The first question, prove that the line joining the centers of 2 intersecting circles is the perpendicular bisector of the line joining the points of intersection. In the figure, circle centers A and B intersects at P and Q. We have to prove that AB is perpendicular bisector of PQ. Okay, first of all, join AP, AQ, BP and BQ. Consider triangle APB and then triangle AQB. Here, AP is equal to AQ. The reason is radii of the same circle. And then BP is equal to BQ. Here also the reason is radii of the same circle. And here AB is the common side for both the triangles. Therefore, we can say that triangle APB and triangle AQB are equal. Therefore, angle PBM is equal to angle QBM. Next, consider triangle PBM and triangle QBM. Here, BP is equal to BQ. Reason is radii of the same circle, and BM is common to both triangles. Okay. Therefore, we can say that angle PBM is equal to angle QBM, which we have proved just now. Therefore, triangle PBM and triangle QBM are equal. Okay, but angle PMB plus angle QMB is equal to 180 degrees. Since these two angles forms a linear pair, therefore angle PMB is equal to 90 degree is equal to angle QMB. Therefore, BM is the perpendicular bisector of PQ. That is, AB is the perpendicular bisector of PQ. Now we have proved that AB is the perpendicular bisector of PQ. That's all for today, children. We shall continue the rest of the questions in the next class. Thank you.